Okay, we are on the bottom one of that paper, increasing and decreasing. So as you come across, again, we talked about how this first part from the left is the slope is 0. It's not increasing or decreasing. So we start here at the number 2 and notice that as we go through, it is going down until we get to the number -1. So that is a decreasing interval, so we're going to list that for decreasing. And it is a solid line, so there's no holes, so they should be box brackets. As you keep going up, 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 this is up, 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 until we get to the very top here. And at the very top is when it starts going back down again. So from -1 all the way through there, it was increasing. You can slide your pencil across the page and notice it is going up. So from -1, comma 2, that graph is increasing. And then again at the top, again it starts going back down, and we use the X numbers here. So 2 to 4. 2 to 4 is decreasing. Find f of 2. Again, 2 is the input. That is x. We are looking for y. So we go to the x-axis at 2. And we want to know the y. Y numbers go up and down. In this case, our line is up here, so we need to go up 1, 2, 3. And so the output here, the y value, should be 3. And at the other spot that we have, it says f of x equals -1. So the -1 is your output. So it is y, and we are finding x. So we go to the y-axis. X values go left and right. We need to go left 1 square, and that is a -1 for x. What does an open circle mean on a graph? An open circle on a graph means the graph gets closer and closer to that point, but it is not a solution. So the graph, the line gets closer to the point, but that point is not a solution. Given that 0 is less than x and less than or equal to 2, write the interval notation. So we're going to list our two numbers. We've got 0 and we got 2. Because the 0 does not have equal. Therefore, is it an open bracket or closed bracket? It has to be closed. Open. I'm so sorry about that. It has to be open. It is not equal. It is open. Not equal, open. Whereas this 2 has the equal to sign, so it is filled in, or it is a box bracket. So, no equal to, open. Equal to, box bracket. That's as easy as it gets. So this one, we're going back to the other way that we wrote it. Remember how we put our two numbers? And it says write it in set notation. We really can use whatever letter we want to, but I might as well use X. Remember that when we are writing in set notation, the alligator wants to eat what's in front of it, or what's after it, because the small stuff is over here and the bigger stuff is over here. So the alligator wants to eat bigger stuff. And here we've got a parentheses. That is an open bracket. So we do not need to put a line underneath. However, on the 4, that is closed. So that is equal to. You do need to put a line, and there you go. Done. same kind of problem as the two problems before. We got negative 3 comma 7. So we put our two numbers. They are both equal. Equal means box bracket. Box it up and you're done. That is the answer. That's an interval notation. You got negative 10 comma 2. Write it in set notation. So negative 10. Put your negative 2. Again, you can use whatever letter you want to. I'm going to stick with X. You could put Y. You could put K. And this is small. This is big. The alligator likes to eat bigger stuff, so he eats what's after it. And they are both open brackets, open parentheses, so they are not equal. We do not put equal two lines underneath, and this is all it is. Done. Given 6 is less than x is less than 8. We've got 6 comma 8. We know it's from 6 to 8 in between there. And notice there's no lines, no equal to, not equal. If it's not equal, we got open parentheses. So 6 comma 8, open parentheses, and that's it. This one, it says, what is f of negative 1? The negative 1, again, is your input. Input is what you plug in. So you've got 6. We're going to plug in negative 1. Put it to the 5th, minus, plug in negative 1 to the 4th, plus 11. Yes, you can do this on your calculator, but I'm going to do it in my head. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1 all makes negative 1. Negative 1 to the 4th is negative 1 times negative 1 times negative 1 times negative 1, which means that it's going to be a positive 1. And from here, 6 times negative 1 is negative 6. A negative times a positive is minus 1 plus 11. So negative 6 minus 1 is negative 7 plus 11 is 4. Your answer is 4. You got your equation. What is f of negative 2? Again, this is your input. This is x. Do you have to care about this? Yes. So you put your minus sign. If you want to put a 1 right there, feel free to put a 1. Don't forget about the negative sign. Then you're inputting negative 2. So put it in parentheses, square it, minus a negative 2 plus 2. Well, I know parentheses comes first, and here I can do negative 2 plus 2 is 0. That's really nice and easy. I don't need the parentheses anymore if I didn't want to, but I left them. Negative 2 squared is negative 2 times negative 2, which is positive 4. But there is still this negative on the outside that comes down. So I got negative 4, take 0 away. That's negative 4. Answer. Suppose you are walking to school. X is time, y is distance. So it says speed up, then slow down. Speed up, then slow down. I think it's best if we read through all of them first. So speed up, then constant speed. Notice this is distance over time. Distance and time. It's not speed and time, it's distance and time. So if you look at each section of the graph, notice the first one is increasing in speed. The slope is getting steeper. And then in this section, the second half over here, the slope stays constant, or the speed is constant. Okay? Notice here, if we break it up, this first part, the speed is constant. And then here, at the beginning, the slope, it's harder to climb here, and as you go, it gets easier and easier as you're climbing this hill. So that is slowing down. This next part, notice it's harder to climb, then it gets easier. So if we split this graph up, harder to climb up, but then over here, you're going to start getting easier, so slower speed. Okay, so now we can just match these up again. So number 4, or speed up then slow down, matches with T. Speed up constant is this one, P. And then constant and then slowing down, that's H. Oh, I skipped some. Okay. Bryn walked to school at a steady rate. We are talking about speed this time. Then realized she was late and ran the rest of the way at top speed. So a steady pace, and we're talking about speed, is just like that. She's going the same speed the whole entire time. And then she speeds up to her top speed. So I would say that she probably curves it a bit because she goes, she's getting faster and faster until she gets to her top speed. Sketch a graph for the situation. Kim has $16 for her lunch money, and each day she spends 3. So we start with $16, and each day she spends 3, which 1, 2, 3, 4, 5, 6. Day 1, you'd now have 13. Then you'd have 10. So 13, 10, 7, 4, 1. And then, you know, you're in the negative. So here, she's got her money, and each day she spends 3 of it. Next. On which interval does Rx have a greater rate of change? Rate of change is again talking about which one is the bigger slope or which one is harder to climb. Steepness. So from negative infinity to 2, this is talking about your x numbers. These are your x's. So from negative infinity all the way over here to negative 2. So negative 2 is right here. So if we look at this graph, this one's going to keep going the same exact that it was before. Notice that this curved line, or r of x, and the s of x would be harder to climb. R of x is really, really easy. So s of x has the steeper slope. We want to know when is Rx steeper. So it's not there. We got 0 to 1. 0 to 1. Well, again, it looks like this curved line is a little bit easier to walk up than this straight line. So that would mean the straight line here, s of x, would be steeper or a greater rate of change. So those have s being steeper or harder to climb. Negative 2 to 0 is in this region here. And again, see, the curve is easier. The straight is harder, which means that the straight again would be steeper slope or greater rate of change. So let's look. 2.5 to infinity. We got, oh, that's 1.5. So 2.5 is over here. And then to infinity. So now you notice that Rx outruns the s of x. So notice that now